When we say flow of current, we kind of imply flow of positive charge. So let's say a wire is connected with a battery, a current conducting wire basically. So this is positive side of the battery or electromotive force, and this is the negative side, and because of these polarities, the positive charge flows in this direction. So that's the direction of current. We conventionally called this to be the current, and this is still our current, but now we know that. So with the battery, what happens, the positive charge flows in that direction and the negative charge will flow in this direction. But now we know actually the current is flow of electrons. So actually electrons flow in this direction, but current is in the opposite direction. So that's what is in when we say current, we actually mean that the opposite direction to the direction of flow of electron, which actually causes the current. So unit of current is ampere, and when we say amp, 1 ampere of current, what we mean is the amount of charge flown per unit time through a cross section. That's what is the definition of current. So how much charge is passing through at a unit time, basically per second. So if we say charge is Q, then ampere will be dq over dt basically, or how much the change of charge through a cross section. If we take a cross section at anywhere, it should be same everywhere through this wire, in a straight wire like this, in a just a series circuit if we call it. So it should be the same amount of charge flowing at any cross section, and the amount of charge flowing per unit time is the value of current. We should remember that the charge of one electron is 1.69 into 10 to the power minus 19 coulomb. So coulomb is the unit of charge, but the charge of one electron is just this much coulomb. So that's a very small charge, of course. So yeah, that's the definition of current. Amount of charge flown per unit time through a cross section. And then again, as we say that we need an electromotive force for the charge to move from one position to another position. Because of the polarity, it will move. So this can also be called a voltage. This is said a voltage. So basically the definition of voltage is the work done. So a work is needed to be done for the flow of charge, for the current to happen, and the definition of voltage is work done. If we call the voltage V, is the work done per unit charge to move one, basically work done to move one unit of charge from one position to another position. So if we say this is position A and this is position B, so to move a charge from position A to position B, if the work done is, let's say, W, and then basically potential is, or voltage is, V is equal to W1 over Q. So if there are 10 unit of charges, then that will be W1 over Q. That's the amount of charge basically. So this is dq over dw over dq we can write, and the unit is, since this is coulomb, this one is joule, the work done, so joule over coulomb, that's the unit of voltage, which is also volt. So these are the very basic two quantities of electrical engineering, we can say. So I just wanted to limit this video into these discussions about these two quantities, which is voltage and current, of course, and we will encounter this always throughout basic electrical and always in electrical engineering basically.